So it's called addTwoDigits. So we're given a 2-digit integer. It's a whole number, 2 digits, something between 10 and 99 inclusive. And we want to return the sum of its digits. Okay. So there are a few different ways we could do this. We'll look at a number of them anyway. I mean, technically there's a lot of ways we could do this, but we'll look at a couple options. So the first one is we'll basically turn this into an array. So we want to get an array of, well, consisting of all the digits here. I guess in this case just 2 of them, but we'll get an array. It'll be made up of the digits here. And then with that array, we're going to use that to sort of add the digits together, basically. That's, yeah, that's the plan. Okay, so we'll start with our array. There are a few ways we could do this. I mean, we could start by converting the number to a string and then converting that to an array. So like, for example, we could say let array be assigned the value of something like n.toString and then .split with an argument of the empty string. Now, if I just do this, let's take a look at what we're getting from that. So basically, yeah, I'm getting this array. It's got 2, it's got 9. Just to be clear about why this works the way it does, the toString is basically just turning this into the string 29 as opposed to the number 29. And then .split is basically saying, okay, so for every empty string you have here, every like non-character, split it at each of those points, and basically anything in between are going to be the elements of the new array. So it's creating an array from the string. Like, we can do this in a lot of ways. You know, we could have like you know, some long word or something like that, right? So here, let's just do return some long word dot split, and we'll split this at the O's, I guess, at the O character, just to see how that works. So basically it's just taking every O here and using that as like a splitting point, and everything in between there is just going to get pushed into that element of the resulting array. So that's what split is doing here. I technically don't actually really like to use split for this purpose, and it's just because I don't know if it's super clear to the reader, in the sense that .split doesn't really have any implication in the name about being related to an array. So one way I like to do this is just put it in an array. Now if we do it like this, it's just going to be an array containing just one element, which is the string 29. So instead we can use a spread operator and run this, and now it contains each of the characters of the string 29. Okay, so this is good. This is maybe better. If we really wanted to be super clear about this, because again, this kind of relies on someone understanding why we need the spread operator. Like, it might not be clear why we need the ... there. So another way we could do this, again, is basically Array.from. So this is a method of like the array object. And we can get an array from, well, a number of things. It could be, in this case, it's a string, but it could be another array. It could be a set. I think it could be an object. But the main thing is that it's some kind of iterable. Okay, so again, we're getting the same thing here. So those are a few different ways we can do that. Now, in this case, we've got our array, and one issue I have with it is it's giving us the string 2 and the string 9. I mean, really what we want to do at this point is we want to put these 2 elements together. So I'm going to use a reduce, which is basically going to say, you know, take every element within the array and do something to it until you just have one element left. So it's a way of putting together all the elements in the array. Specifically, you know, we're tempted to do something like this, A plus B, right? For every A and B you have in the array, add them together. But this might not give us what we're expecting, because these are strings, right? It's the string 2 and the string 9. So when we add those together, well, it's looking at this plus sign and saying, oh, that doesn't look like addition to me. That looks like concatenation, because we're dealing with strings. So it's basically putting the 2 strings together, the 2 and then the 9. It's one string. This is basically useless. I mean, this is basically just like doing n.toString. You know, like everything else we have here is just undoing itself at this point. So that's no good. One way we could deal with this would be to actually put like a parse int on each of these things to say like, no, I don't want the string 2, I want the integer 2, and I don't want the string 9, I want the integer 9, I want to add those together. And that works. You know, like we could use this, no problem, submit it, it works, it's fine. But could it be better? Yeah, I think so. So first thing I wanted, that's nice of you to say, but no, not right now. Okay, so first thing I want to do, because I do kind of prefer, and this might be just an aesthetic thing, I don't know, but I do sort of prefer just having the a plus b there. So what I want to do instead is, before I even do the reduce, I want to do a map. We're just going to take every element in here and just take it to parse int of that element. So it's just going to map each of our string characters, you know, like the string 2, the string 9, and it's going to map them to the number 2, the number 9, or whatever they are, and then it's going to reduce from there. Okay, so I like that a little better, I would say. I guess we should start doing this like we used to, you know, for tradition's sake. Let's make a new function here, and we'll just say that's addTwoDigits 1, because I want to do this in a slightly different way now. So we've used an array at this point, but if you remember last season of JavaScript the Game, close to the end, we learned about a new thing called a typed array. So here's the documents for a typed array. I really like these things. I mean, basically, they're going to use up less memory than like just a generic array. They have some restrictions on them in the sense that we can't just keep extending them with like pushes and pops and stuff like that. We sort of have to have a fixed size. But because we're constraining it, you know, because we're saying, no, it can only take this type of number, no, it can only be this length, we don't need to build in as much of like a safety net, I guess you could say, in the sense that like, oh, well, what could go wrong? Like we can make more assumptions in terms of what's going to happen here, in terms of what this stuff is going to look like. So we don't need to be prepared for as many other possibilities. So in this case, we're really just using an array that consists of like numbers between 0 and 9, like it's digits, right? So because of that, I'm thinking it would be totally appropriate for us to use like a uint8 array, unsigned integer. I mean, this is way more than enough values. This is definitely enough for us. So there's a variety of ways we can instantiate a new one of these. But let's see. I mean, it's got the .from that we had before with our regular array. So maybe we'll try just doing a .from. So here, let's try this. So uint8 array .from and .toString. So I'm going to run this, and notice, okay, first of all, we see that it's working. You might think, oh, well, it's just working because you have this other one here. And the answer is no, because it's looking for something called addTwoDigits. You know, it's specifically when it runs the test, it's looking for a function called addTwoDigits. This one's called something different. It's addTwoDigits 1. So just to prove that, I'm going to delete that and show, yeah, it still works. But here's the other thing. I mean, I talked about some of the advantages of these typed arrays, the fact that we can afford to make more assumptions, and therefore it's going to take less memory ultimately, which affects performance time positively. And so basically the idea is that that's a huge advantage to a typed array, but there are other advantages too. As soon as we make this thing, it's going to take those strings, you know, like we have the string 2, the string 9, but it can't take anything, like it can't handle a string. It can only handle numbers from 0 to 255, you know? Where was that? I think it was on the previous page. Yeah, it can only handle these things. It can only handle integers from 0 to 255. So because of that, it's going to say, oh, well, you're trying to give me the string 2 and the string 9. I can't do strings, but I'll give you the number 2 and the number 9. And it's like, well, yeah, that's actually exactly what we want. And that means, can we get away with not doing the map here? Yeah, we can get away with not doing the map. So that's pretty nice. I like that a little better. I think performance-wise, this is better. And in terms of readability, I would argue that it's better just because, you know, we don't have a map and a reduce. We just have the reduce. Then again, this might be a little intimidating for some people if you're not familiar with typed arrays. I know I wasn't until very recently. So well, I guess it's got the word array in it. Anyway, look, if you've got an opinion of it, you can let me know in the chat. As for now, I am actually kind of curious. I haven't tested this or anything, but when we were just looking at this, I mean, I noticed this here, right? Like new uint8 array object. Like it could take object as an argument for the constructor. So maybe we could just do it like this. Like instead of a .from, just put it right in there. I don't know if that would work. Let's try it, I guess. And no, it doesn't. Okay, so we'll keep it .from. Let's try running that again. And yeah, there we go, it works. So we'll just make sure it passes all the hiddens as well. And it does. Okay, cool. So that's pretty neat. I like that. I think it's pretty neat. But we're not done. We have another way of doing this. Because, we're looking at this and we're thinking, okay, I mean, that's cool. I especially like this one. But, we're converting the number into a string. We're making a new array. We're holding it in memory. It's taking up more space than we need to. And it's probably just more operations than we need to be worrying about here. Like, why bother converting something to a string and then an array if you don't have to? So I'm going to try to take a look at this in such a way that we don't actually convert it at all. I basically just want to keep this thing a number, but allow it to do what we want it to do. So, I mean, if we could just do something like return n.addDigits, or let's say .digit sum, digit sum. There we go. Cool. n.digit sum. Return n.digit sum. Something like that would be cool, right? We run that and it would just give us like the sum of its digits. But no, that's not a function. That's not like a built-in. So, maybe don't try this at home, but just to sort of show you one thing we could do if we did want that, we could say prototype. Not just any prototype, number.prototype dot digit sum. This assign the value of this function, which is going to take no arguments, and it's basically just going to add up all the digits. So how are we going to do that? Well, let's start with let sum be assigned the value of 0, and we'll say let n be assigned the value of, can I just do this? Is that possible? Let's see. Let's just do return n plus 5 for now. So it's not really digit sum, it's just adding 5 to the number. We'll see if that works. Yeah, 29 plus 5 is 34, so I guess that's working. Okay, so great. And then I'll just say while n. Okay, so this is a loop that's going to keep firing while n is non-zero, basically. So that's the only time it could be typecast to false. So as long as it's some number which gets typecast to true, so anything other than 0, then this loop will keep going. Now what's the loop going to do? Basically, I want to extract a digit for every pass of the loop. So how are we going to do that? Well, basically, we could say something like let digit be assigned the value of n mod 10. That's just the last digit. If we were to take this 29 here and divide it by 10, what would the remainder be? So 10 goes into 29 twice for value of 20, which means that there's a remainder of 9. And 9 happens to be the last digit here. Well, I mean, it's not a coincidence. If we take 11 divided by 10, remainder is 1. 1 is the last digit. We take this 99 mod 10, divided by 10, remainder is 9. 9 is the last digit. We take this 39,358 divided by 10, the remainder is going to be 8. Etc. We could do this with whatever. So basically, this is just the last digit here. Okay, and I basically want to say sum plus equals digit. And then after that, I want to reduce the value of n. Basically, I want to cut off that digit. Just chop it right off. So how am I going to do that? Well, first I'm going to divide this by 10. So if we were to divide this by 10, it would become 2.9. It's like, moving over the decimal point. So we get 2.9 by dividing that by 10. If we round that down, so if we do a math.floor, it would just give us the 2, which is what we want. It's basically the number without the 9. Again, returning to the 39,358, because it's a nice long number, a good example for this case. If we were to divide that by 10, we'd get 3,935.8. Round that down to a math.floor, we get 3,935, which is exactly the part of the number we want. It's the part of the number that doesn't have the 8 at the end. So we're going to say n is going to be assigned the value of math.floor of n divided by 10. Okay, so basically this gives us the digit, this chops off the digit from the end of the number. That's the idea here. And then at the end of this, once it's done that whole loop, we want to return sum. That's what we're getting here. We're starting with a sum of 0, and we're adding on the value of each of the digits. So this should really be giving us our digit sum. But let's just run it and make sure that's true. Yeah, there we go. It's giving us our digit sum. Now this is definitely overkill because it's kind of more general than we need. In fact, check it out. Like I could just put this in up here, and it should still work, I believe, because we're basically modifying the way number works for like everything within this scope. So, okay, great. And I mean, like we could do something like this as well. We could do like, here, let's just say let num be assigned the value of, let's go with, let me just pull a random number off the top of my head. Let's go with 39,358. And we want to do num.digitsum just to get the sum of all these. I guess I should have prepared and actually got the digit sum here, but let's see. So 3 plus 3 is 6, plus 9 is 15, plus 5 is 20, plus 8, 28. Yeah, it's 28. Okay, cool. So this is working for larger numbers, but we don't need it to work for a larger number. We could just say n.digitsum. And yeah, there we go. Okay, so that's kind of cool. It's sort of neat, like changing it's kind of like changing the capabilities of an object almost. They call this, okay, so when we're extending the capability of an existing object, like a built-in, apparently the name for this is monkey patching. And it's pretty frowned upon. I guess you don't really want to be doing this. There's a lot that could go wrong. There could be like collisions of these things. So in general, they say like probably don't modify an object that you didn't create yourself. I guess that's just sort of a rule of thumb. Anyway, point is we've got 3 pretty interesting ways of adding up the digits. But like we were saying, keep in mind, like all of these methods would work for bigger numbers. We have guaranteed constraints here that the number is between 10 and 99. Yet we're kind of ignoring those constraints in the sense that all of these that we've done so far could easily be extended. Well, not like they could be directly applied to larger numbers, like we saw with the 39,358. Okay, so what's that? 3 is the third one. Yeah. Okay, so since this one is just 2 digits long, I'm going to do this in a different way. I'm just going to say, well, look, the last digit here is going to be n mod 10. And the first digit is math.floor of n divided by 10. So maybe I'll put that one first. Okay, so let's try that. Just the first digit, second digit, yeah, that's all we need. Now keep in mind, this one would not work for larger numbers, but all these other ones would, no problem. So, it's kind of interesting, like I generally like to sort of think about how would we deal with this, how would we make like just a generally efficient product here, like disregarding the constraints, like how could we make something that's going to work for whatever we might want to try it with. But at the same time, what I'm starting to notice is that for a lot of these algorithms, sometimes the constraints can sort of allow you to make an assumption that can really speed things up. So, it's worth considering. Well, here's an example, right? Like we don't need to worry about all this stuff. We don't need to make any new arrays or anything like that. We don't need any loops. We just say, oh yeah, this and this, big O of 1, no problem. Okay, so did we submit that? Let's just make sure. Yeah, okay, it's passing all the hiddens. I think we're good for that one. If anyone has any questions, comments, concerns, feel free to let me know. As for now, well, we've got a few more of these to get through, so